All right, well, why don't we start? This is Charliecloud development for noobs. There was a better title in the program. Deanna's here, so that means we can start. I think the first thing I wanted to point out is what I'm skipping over, which is that we have, so this is the Charliecloud GitLab page. We have a wiki, right, which is under plan, I guess. And I just wanted to point it out because we have this, we have a detailed installation guide. Like, this is sort of developed over time as we figured out what kept confusing the students. So it's assumes less about prior knowledge on how to put together Unix software, especially squash views, which tends to trip people up. But we're going to start from a state where I do have a working virtual machine. But we're going to pretend that I'm that I'm a new developer, but I'm interested in Charliecloud, right? So we got to get the code somehow, right? So this, and if you're not familiar with GitLab, it's similar to GitHub with a few differences. Anyway, so we can start by git cloning source code. Go into here. So I just need to do SSH. Why did it not want me to log in? Can I read from repository? I swear this worked last night. Oh, we're on the wrong computer. So what we need is a new shell. So I can actually put the problem is that my SSH key expired from the agent overnight. So we have to put it back in.
I think the real problem is you have too many windows open.
That's, so this is a statement you get from younger colleagues who are weak.
I was going to say you don't have enough open.
This desktop is really sparse. And once the camera's not rolling, I can show you some real desktops. Okay, what do we want to do? So, okay, so now we have the public key in there. So now we're going to clone it. Oh, and I can show you something, which is that I have this browser extension here that tells me how many windows and tabs I have open in my browser. 488 windows. Yeah, so he gets it. This is how you greet Megan in the morning. All right, so we have Charliecloud. We can go in there, and it's a fairly standard Autotools build, right? So we can, I mean, LS is a good first step, right? One thing that you might notice is that there's no configure, right? This is common for Autotools projects. When you if you get a tarball, this step will have been done typically. If you get it from Git, we need to do this. So we'll do autogen.sh, and this actually does two things. It sets up the Autotools stuff, and it also downloads the Lark library, which we embed so that you don't have to have it on your system already, which is optional. You can use the system one if you want. Anyway, so then we do configure, and you probably got a preview, but I'll explain what's going on here and why. And we don't need to do all three at once. So this is just my preference. I wonder if these are going to get bleeped before they go onto YouTube. You don't have to do this, but this sort of reflects my preferences. So C flags, you know, this is things that we're going to give to the C build. I like to build with no optimization because that makes debugging easier. This includes debugging symbols. And And I like the build to stop at the first error. And then, because that's the one that I'm most interested in, because it can be cascading. So that's what this variable is about. Configure is routine, and then I give it a prefix so that I don't try to install it into user local by mistake and mess myself up. So we can configure. And one thing that Charliecloud does that I think is pretty neat is we get a actually fairly extensive report at the end about the things that it's found. So this is often useful for checking to see what you want to do. If you want to be a Charliecloud developer, it's often helpful to get everything to be yes. So a couple of notable things that tend to trip people up is, so JSON, so there's the libc JSON, that's just installed on this. This is a Debian virtual machine. So we have that enables the CDI stuff. This enables the squash fuse stuff. So we need a lib squash fuse development package that's sufficiently new. If you like Debian-based distributions, this is usually up to date. If you like Red Hat, Godspeed. So those are some key things. But you can dig through this at some time if you want. Okay, so we've configured it. Now we do make. It's pretty quick. That was the whole project. And then a real quick sanity check. So if we ls here, the C stuff is in bin, right? Or the C stuff and the executables are in bin, right? So we could do bin chrun, and we can ask it for version, right? And this, that's a sanity check. That's the C program, and then the Python thing is also version. So that all works. I guess one quirk that we could show right here is the Python programs get a very lightweight pre-processing step, and that's that they get the Python shebang line shoveled in at the last minute. Right, and that lets you give them a Python that's not the default Python. Okay, so now we have a Python, we've built it, it seems to more or less work in a very basic way. So now we need to decide on something to work on, right? So to do that, we go to issues, except like in the last 24 hours or something, they've become work items, which I'm a little confused by. Oh, by the way, this is how you get a very large number of tabs. Just open every link in a new tab. So now we have a long list of things that we could work on, right? And how many do we have? 305 open work items. So we could pick one at random. In this one, it turns out that I'm already working on it. In fact, there's a merge request for it. So this is not a good choice, right? So let's try again. What we can do is pick another one at random, and in order to be even more random, I'm just going to type in a number. So we can work on this one. This is a sane scope for doing it in an hour, right? So we're like, okay, this is a confusing error message. You get this if your container image is the wrong architecture. And it confuses people who work in Consult. So we're going to give it a better error message, right? So we go to our source code, and we're going to use VS Code because I just want a new window. Because young people showed up at my work and convinced me that VS Code is easier to use than Emacs. And I'm really sorry about that. Anyway, so It's in a virtual machine, right? And I'm using a local editor, so we can, many of you will be, whoops. Many of you might be familiar with this, right? But we're gonna connect to the virtual machine, right? Happens to be the first one, because I did actually practice this last night, believe it or not. And okay. This is funny because last night it also installed a new version of the VS Code server on the virtual machine, like 12 hours ago. So it has to think very carefully about that. And we'll just wait for that. We do want a branch, right? And I like to do that type of thing in a terminal, right? So we can do get checkout. What is it? Is it -b? Yeah, there we go. So you can give it a tidy name, right? So a quick summary, and then the issue number is 1898. All right. And then I like to double check my get stuff frequently so I understand the state. And where did it go? Oh, all right. So Angelica has been working very hard on the compose stuff. But if we search, right? So now it just points to main. But we're on a branch, which is what we want. This is a standard way to work for on Git. Connected to remote. Okay, so now we need to actually open the source code. This one I put in /temp. Here we go, Charliecloud, and we can open that, right? Oh, and it's restoring state from last night. So this is tiny. We can make it much bigger. Is that okay in the back? Okay. All right, so we want to fix this, right? We look for it's like, well, where is this? Turns out that this error message has actually changed slightly since we last did it. I'm going to skip over that part, but it now talks about exec VPE. And so it appears, let's see. This is interesting. So it's following some test fixtures to show multiple files at once, right? But the ones that matter, we have a C file. Oh, it might be useful to give like a very quick overview of how the source is put together, right? So, oh, and I'll show something else that's neat that I like to do. So I like to export the virtual machine's disk using Samba back to my laptop, and then I can use the Finder to dig into it. So that's what's going on here, and you probably can't see it very well. Okay, I don't know if this is useful at all. Let's go back to VS Code. But this is just Lucas, the virtual machine, you know, and so this is the source code, but the text is too small for you. This error message comes from the C code. The C code lives in bin, right? We have, and the gray ones are excluded by git ignore because they're derived files, right? But chrun.c, that's where main is, you know, various stuff going on. core.c and misc.c is what we're going to be seeing, no pun intended. So we have to find that error message. It's an exec VPE, and now it talks about exec VPE, right? And so we can see, okay, here's a exec VPE call, right? There's another one in misc.c. These are aliases due to symlink fixtures for testing that are not excluded for some reason. We're also seeing it show up in chrun misc.bats, right? These are going to be, well, we can just, oh, that's the fake one. This is the real one. It's in test run, right? So has anyone in this room heard of bats? Not the animal. It's Bash automated testing system, and it's basically lets you write tests as shell scripts, and it'll run them. So we have a large number of tests that are bats at the moment. I want to change this, but this is how it is at the moment. So this runs a command and captures the output, right? And then we're validating the output status and we validate the error message, right? So this is testing that the error message that we're about to change is what we expect, right? So we can look at the C code. This is where it is, or that's the call. We have, I think this is actually a reasonably well documented function. So Charliecloud, does the containerization stuff. Eventually we get to run user command, and that replaces the Charliecloud process with the user command that we actually want to do, right? That's where exec_vpe comes in, right? And so this is Doxygen syntax, though we don't actually build anything with Doxygen yet. I was experimenting with, can I actually document using this, and does it make sense? And it seems to. Oh, I know what we need to do. So one of my quirks is I always think a lot about how wide files are. So I have this line set up for 80 characters wide. Anyway, so run user command runs the user command. Do some validation, and I guess we're redirecting to dev null. Eventually we call exec_vpe. Exec_vpe is a little bit neat because it only returns if there's a problem, right? That's weird, so that's where the comment is. So this is one of them, right? Then error is a macro that we wrote, and it basically formulates an error message. Something that you'll also see is these things. So this one, ZFE, it validates that the first argument is 0, aka false, and then it includes a formatted error message. This one happens to have no arguments, and it includes the error no. Because sometimes the error no is meaningful, sometimes it's not when you call C library functions. So we complain, and then we exit with our failure exit code, right? So that's one of them, and if you might recall, we have two. So the other one is in misc.c, and that's right here. And so one thing that I noticed is that this code is very similar, right? So that calls for a refactor, and this will be quick, right? We have a lot of these wrapper type functions, right? So we can do command args, right? And then I'll remove this, right? This, this function should probably also go in misc.c, And of course, because this is a relatively short demo, this is going way faster than an actual new developer would be going. But, you can converse with us and be like, well, okay, where do you think this should go? Or better yet, I think this should go here. What do you guys think? Right? So it's going to need to go in two places. Functions. Oh, this is actually a pretty small file. Okay. So we're going to want to match the function signature of exec_vpe, which I don't 100% remember. So that's what man pages are for. And there's a subtlety here that, so the one we want is this one. This is a library function, and it calls the corresponding system call. So we can just copy and paste this. So what we'll do is, where do we go? Okay, so this function is never going to return, and that's kind of a style we have. I like to write functions that either succeed or bail out. That seems to work to fit our model, right? So we have no return. Do I need to put a void? Okay, so it's going to look a lot like run user command, right? So it doesn't actually have a return type. We're going to do exec vp ch. I think this should be called path. Right, so then, so far this gets the existing functionality, right? Oh, and this keeps confusing me. All right, so this is path argv fp, right? So if we go back to the issue, so I like this suggestion right here, right? So if we look at, we can look at errno, and we can search for, remind myself what that is. So what was it? No exec format error, right? And that's the error message that we saw in the thing. So where we go. All right, so if we get to here, right, we know that we've failed, right? But we're going to try and be a little bit more helpful in that specific case, right? So if we can do if errno equals what was it, no exec? Shit. Yeah. Where did we go? Okay. So if that's the case, error no. We can do something like I might want to wordsmith this at some point. But the keyword is, or the key concept here is that we might have the wrong architecture, right? And command. We want to include the thing that we are trying to do. Like if you're here for the philosophy talk, one thing we like to do is try and be explicit. So it seemed valuable to say what we were trying to execute. So that's the path right here. And this line is kind of long. So the line is too long and the message is too verbose. So I'm just going to punt for now, right? Otherwise, something else went wrong, and we're going to go back to the previous behavior, right? So I think that this is likely to be correct. Maybe we can. That might work. Okay, so now we have this function. I think it's more or less correct. We now need to add it to the .h file, right? And so function prototypes, right? Okay, so there's a prototype that goes in miss.h, and then we can in core.c we can just do the wrapper. Oh, and there's one other step that I wanted to do that we like to do. And some of this is like, here's some sample quirks. I don't know if, there's not a test. All right, so we replace it with a wrapper. You can also pretend that I wrote really nice documentation for that function. So now we can replace that with a wrapper, and then I forgot what we were doing next. So another thing that we do is, so we have a lot of these wrappers, right? We do a preprocessor trick to prevent people from calling the original, to avoid those sneaking back in. So what we can do, I don't 100% remember the syntax, but here's a sample, right? Disallowed library functions, right? So we also are going to want this in miss.h now. I don't think there was any of that previously, right? So, and it's, so we're gonna define that as function blocked, and then in the C file, I think what we do, is it undefined? And then, so you, and of course you have to unblock it once you're in the wrapper because you want to actually call the function, right? So, okay, undef, and then we redefine it, right? So we can do undef ch, and then at the bottom, okay. We could look at the diff if we wanted. That's always a good idea, in my opinion. And we're gonna close all this. All right, so we added this. What I'm looking for is, did I do anything obviously stupid, in hopes that it will actually compile on the first try? Right, okay. So, place your bets. Check. Function blocked. Oh, somehow I'm blocking it in the header files. What have we done here? Okay. Well, I don't want to debug that live. So what we're going to do is just comment this out, and I will, my hope was to actually merge it in this session. I'm not sure that's going to happen, but we can send it for review. What?
You have an error on line 33, CMD variable doesn't exist.
Oh, you were right. Good catch.
I keep debugging, I want this merged.
All right, we can try. It's so exciting. Somebody just left, Megan.
Russ, top, get this merged. This will make my life easier.
That's why this talk is for me.
It actually is.
I know.
Oh, and we're gonna comment this out.
I find it exciting.
Yeah, and to some degree, actually, Elena, who's sitting behind you, because we're trying to get her into the Charliecloud fold as well. Okay, so let's try building that again. Okay, so that worked. We should test it. See, that's fine. Do whatever you want. Don't worry about it.
That was because I said.
What did?
Oh, when I said this talk was for me.
Oh. It is pretty low level. Okay, so what do we want to do? So we have that one image. So let's do. So this is an ARM64 virtual machine. So we're going to deliberately pull an image that is the wrong architecture. So let's pull. Sure, that looks good. I think what we do is arc x86 64. Is that going to work? AMD 64. Oh, so one of the things about OCI, their list of architectures is different than Linux's list of architectures. And I have no idea why.
And it's different between like Red Hat stuff too, right? Like doesn't like Podman or something have like Red Hat, sometimes Red Hat images will be like tagged ARM64 versus ARM64.
Oh my God.
So yeah, they're like their own way. So it's even more of a nightmare.
So the question is that there's a third scheme of architecture names that Red Hat uses in their tags.
Yeah.
And somehow I'm not surprised. Arc equals AMD 64. Okay, so let's try and run that image. And let's do lots of verbosity because that might help us. But so we have oh, I know. I'm going to prove that it exists. List, right. So now we have 2 images in the store. Oh, and for this is a Charliecloud developer talk. We can take a quick aside. So there's the storage directory, right? I mentioned this in one of the other ones. By default, it goes here. You can put it wherever you want. There's an environment variable. What's going on in here, right? So BU cache is the build cache, right? You know what? Let's even push D into there. Right. So BU cache is a Git repository, right? And then BU large is probably empty because we don't have that enabled. And the quirk there, so this is large file support for the build cache because in order to store a file, Git has to read the entire file in order to compute the digest. If you're storing a giant file, maybe you don't want to pay that price. And so you can configure large file support. It's a command line option, and you can change it sort of like whenever you want, I think. Doesn't have to be set permanently. But it instead of storing the actual large file, it just stores its metadata and it puts the large file over in this directory in BU large. And the funny mistake I made when I was originally implementing this is that I assumed that hard links were copy on write, which they're most definitely not. Because performance, right? I didn't want to actually copy the file. So what we do now is actually something really neat. We use ref links, which is a copy on write type of link. And that's very cool, but only certain file systems support it. And I think that I'm pretty sure that this one does not. Yeah, so this is on the ext4, which doesn't. If I recall correctly, it was ButterFS, XFS, maybe ZFS. I don't know. I'm pretty sure it's not ext4. Anyway, what were we doing? DL cache, this is the stuff that we download from the repository, right? So these are some manifests. These are various JSON blobs. You know, these are the 2 configs that we got from these 2 images we pulled. Each of those is probably a 1-layer image, and these are the layers, these tarballs. We'll skip over image because that's the interesting one. We'll look at it in a bit. This lock file is just a file that sits there, and we lock it because I'm not yet smart enough to do finer grained locking in the the storage directory. UL cache is going to be empty right now, I think. This is where we put the tarballs when we make them in order to send them up to the registry. And then version just says which version of the storage directory it is, what format it is, 7. We've been 7 for a while.
I have a
And
question on this.
Yep.
The storage directory, so I'm one of those crazy people who actually sets the environment variable, puts in our storage directory out on fast. Is that, on a scale of 1 to 10, how dumb is that? And why is it, like, if it is dumb, why is it dumb? In the sense that, like, I like to do builds in flux match jobs. So that way I know that the cache is available to any node that happens to get assigned or allocated during the build. But I have noticed when I do this, Charliecloud is pretty touchy about that directory, the storage. Like, so it'll, you know, whatever directory you set, I think it wants it to be empty or something like that. Like, it does some checks on it, and it's like if you've already previously used it for Charliecloud or something, for reasons, for some reason for me, it's just like you shouldn't be doing this or something like that. I get like errors.
Yeah, so we could talk offline about specific errors, but it should work. And the check it's doing is that it wants to either create the directory you tell it, or it wants it to already look like a storage directory.
Okay.
So a common error people make is to make the same directory they tell it to be the storage directory.
Right. Yeah.
But if it's an existing Charliecloud directory, that should work.
Okay.
The question itself, I think, is actually a pretty thoughtful one in the sense that on our HPC systems, we have fast file systems and we have persistent file systems, but not both, right? So the choice you made was to put it on a persistent file system. In my experience, container builds, if you're compared to local ephemeral storage like TempFS or NVMe, it's like 3 times slower or more on NFS. And a value add that I am interested in for Charliecloud is being able to put the different parts of the storage directory on the different file systems to get the properties we need. Which you could, I mean, you might be the kind of person who could symlink things around and see how it would work. Right, so specifically, I think what you might want is, I think you want BU cache and BU large on persistent storage, and everything else can be ephemeral. I think it will figure it out. The trick is going to be Charliecloud won't know how to recover a storage directory that has partly disappeared, but you could magic that somehow. You can look at the checks; they're not very sophisticated. Yeah, so if you do that, please let me know how it works. And then an image, this is where we store the images that CHImage is operating on. So if we go in like Alpine, Alpine, and there's some encoding here, right? So it's not Alpine :318, it's Alpine plus 318, and that's because, so the principle here, we want directory names that are acceptable to both the shell and Git branches, right? And so I believe the colon is offensive to Git branches, and so we encode that as plus. So if we go in here, you know, it looks normal. What was I looking in here? Oh, and then there's this, there is actually a point here, I swear. If we look at CH, that directory has some Charliecloud metadata. Notably, Git, this is a Git working directory, right? And it's pointing back to the BU cache Git repository, right? So every image is sharing the same Git repository. And then you can go the other way too, like if you do view cache work trees, right? These are directories. I don't remember what exactly is in here. Oh, there's some Git stuff. Oh, and something kind of cool we can do chimage. We can examine the build cache in a few ways. And that's kind of cool. It's not supposed to be, sorry, okay. Sorry, I'm talking to myself. I think there's a couple of things here that are kind of cool. So we could do git, or no. We could do chimage. We could spell, in theory. Build cache tree, right? So this is showing us a few things. One is sort of some statistics about the build cache, right? There's 3 named images. You know, you can see there's root, the John, Alpine, no large files, 3 commits is a pretty basic tree, you know, some small number of files, that's not very many. Anyway, I think this is really neat that you can actually see the tree structure of the build cache, and this is like all the images that you've built or pulled. You can also write dot and tree. Okay, we'll try this. If it doesn't work, I'm not gonna debug it because this one is fancy, but can be difficult. But there's a okay, we didn't get any errors. Let's see. Oh, this is a good opportunity to use the Samba stuff. Right, so this is the virtual machines file system tree, and in temp, what this did, it produced these 2 files. It produced this GV file, which is a dot graph, and then foo.pdf is the rendered graph. We can open that, and it will show us in a graphical way the build cache. I think this is pretty cool. I've also distracted myself hugely and forgotten what I was doing. We went to an aside to look in the build cache. Oh, one other thing that we can do that's pretty neat is garbage collection. So, oh, and it actually worked. So I was skeptical because it's so tiny. But one thing that Charliecloud can do that layer-based build or layer-based container implementations can't do is deduplicate across the entire set of images that you have. That does not care about the ancestry. And there's that might be part of why we saved our 8 megabytes. There's other things that it's doing as part of the Git garbage collection. But I just think that this is really neat that we can. Git is a really powerful tool, and there are a lot of people smarter than me working on scaling it. And that's why it seemed like it was a good bet to put weird large things in it like container images. Where were we? Oh, some of the other metadata that might be interesting. Metadata.json. So, as you probably know, Git doesn't store a lot of file metadata that we might care about. So what we do is record that metadata, we put it in this pickle file, and then we can recover it to work around that. All right, so what are we even doing? So it built, right? Oh, we were trying to test this bad image. Okay, right. So we're going to do chrun -vv, and the image is Alpine 3.18, right? And then let's try bin true. Oh, I know what went wrong. And this is something that can also bite developers. One really good way to get yourself confused is to install Charliecloud packages from your OS and then do Charliecloud development. So that's generally not advised. Something that I do, and that this is where this came from, is I'm usually working in this directory, right? So that's the ch run we got, right? And so the reason it's in my path is so that I don't have to keep typing the specific path to it, because it usually works. But what we can do is, instead of that ch run, we can do the ch run that we actually patched, right? So this one gave us an acceptable error message, hopefully, right? Is that acceptable, Megan?
Yeah.
Close TikTok. This is statistics from the garbage collector, which I'm interested in. It actually, I don't know. I just think it's so cool that you can do garbage collection in C code. Okay, so we're reasonably happy with this patch. And so this part of the Git stuff I know how to do in VS Code. And we looked at the changes, right? So we're gonna start staging those. I always encourage people to look at their diffs when they commit and don't use the add all, because who knows what crap you're gonna put in there. And I will find it when I code review you. Anyway, so we can name it something. We can do the commit. I prefer to then push it from the terminal. And what do we do? We want git push. Oh, okay. So something that I also recommend. We'll take a digression. Oh, I didn't actually do it here. Okay, we can do it live. I don't like this. I don't like the default naming of the remote as origin, because origin could be anywhere, right? And especially at the labs, we have these internal repositories and external repositories, and like if we do, if you look at where I actually do work, yeah. So this one is less exciting than some of them, but so giving the remotes a meaningful name, I think, is useful. So we can do git push gitlab.com. I think we want -u. Okay, so we pushed our thing. GitLab helpfully gives us a URL that we can hit to create a merge request. It also shows up if we go over to plan, manage, code, merge requests. This is a quirk of GitLab. This is what GitLab calls a pull request. Right, and here it's also, hey, you just pushed. So we can create a merge request. Oh, and something else that I had forgotten to do. This one is assigned to me, but it was still in status incoming. I'm actually working on it. So we have status in progress, right? It's assigned to me. These are the labels. We don't use parent and await. We do use milestone, right? So I think it's pretty likely this is going to get into .44, and I think that's about it. Okay. So now we want a new merge request. This title is probably fine. I'm going to mark it as draft because of that function blocked thing. And then I can say closes number 1898, right? Oh, and plus is useful. All right, we don't assign the milestones to people. The reasoning here is that, so GitHub has the same number pool for both pull requests and issues. So you cannot have a merge request with the same number as an issue, and you can kind of treat merge or pull requests the same as issues in various ways. In GitLab, there are different number pools. You can have a number collision. And so what we've done is we have the convention that the issues are the only work items that matter. If you have a merge request, it needs to have an issue attached. So like if a merge request, if you start with a merge request, you would also create an issue to attach it to keep us sane. Good, so we're gonna create the merge request. Okay, and so here, this is a pretty short description, but it says closes. Oh, and one thing that I wanted to show. So this is a pretty good bug report. One thing I do like to do is we have a format that is helpful. Pinned work items. So if you report a bug, whoops, and it encourages you to there's a template, right? What's the summary? Here's the steps to reproduce. What was the expected behavior? Sometimes that's really hard to infer if people don't write it down. What's the actual behavior? Comments. We don't actually need a new issue. Discard changes. Forgot what we were doing. Okay. Okay, right, okay. So the next step is also important. We have a CI pipeline, and I swear I'm confused because this seems too small, but maybe I did not merge that.
It's because of draft.
No, it's not it. I think I didn't merge a merge request that I thought I had merged, because it's getting way better. Oh yeah, okay, so I'm working on this one, test arm on gitlab.com. There we go. 75 jobs, that's what I wanted, but I haven't merged this one yet. Because this is expanding the architectures. Right, we're doing AMD and ARM. So then when you get to build test, there's a lot going on here. Oh, 27, right? There's a whole bunch of variants, right? So we have architecture. Are we building with garbage collection or not? What is the distribution? We try 3 of them. The dot here has to do with where the Charliecloud is installed. That's like, did we build it from a tarball or from source? Did we install it or not? That type of thing. And then what format are the images in that we're testing? So that's why it's too small. But now we have this pipeline running, and this one, we can just look at this quick, and then, Megan, how long is this session?
10, 20.
10:20, okay.
When the food comes out.
Right. Oh, and it passed. I wanted to look at one that was in progress. So Debian's my favorite distribution, so I can look at that. And this is, I mean, this type of thing will look kind of similar to like other CI stuff. The neat thing about GitLab is that you can run your own instances very easily. So they tend to be like all over the place. We have lots of these that are internal as well. This is pretty verbose, right? Oh, this is a fun trick. If bash is available, the shell scripts that we have re-execute themselves into bash. And that, I think that there was a reason for that, but I thought that was pretty cool. You know, so we get a lot of information. One thing I do that I both love and hate is we print out the entire environment, because I got tired of trying to guess which environment variables I would care about. And there's a lot of them. There's a lot of CI stuff. You know, it just keeps going. This one is kind of spectacular. Right, and there's, you know, information about locale, stuff like that. This validates something, I forget. UMask matters, right? Okay, this is actually running the test suite, right? So scope quick means run a relatively quick set of tests. Hopefully, if something egregious is wrong, it will fail quickly, right? You know, and it's like, this is the run we're using, this is the bats we're using. You can also run this locally. Like, I spend a lot of time trying to get developers to actually have test suites that pass on their machines. Because it's the, okay, there's two things going on here. One, because it's the test suite at all, it's kind of picky, right? And so there's some configure things that are necessary to make the test suite pass that matter less in actual practice. And then the test suite has something that we call pedantic mode, where it has even more picky tests. Like, there's a sudo configuration that you need that like lets you go into a new group but remain yourself, or something like that. It's obscure. That will fail if it's in pedantic mode, and if your name's in the README, it will be pedantic mode automatically. Yeah, so right here, it's like you're not in the README. More data. Do we have sudo? Oh, this kind of excites sysadmins. I've gotten a number of emails saying like, why do you keep trying to sudo? And I'm like, I'm just seeing if I have sudo in order to run the right tests. They don't like it. Right, and then we get into different phases, right? So it's building some test images, it's executing some build phase tests, skipping some of them, right? Because this is quick scope. So we have an rsync instruction that extends Docker files, that does well-defined things with like all sorts of weird stuff the rsync people have discovered over the years that the Silicon Valley kids did not think of when they wrote copy. So copy is both underdocumented and inconsistent between different builders. So that's why we made rsync. And I think it's really cool. So there's the cache tests. Okay, and then it's a bunch of run phase tests. And these are all just shell scripts. Oh, and then this is working around the fact that the artifacts we make are way too big for GitLab. Like, GitLab knows how to transfer artifacts between jobs, test jobs, and it just like tars things up, or no, it zips things up, transfers them to the dependent stage. That counts against our storage quota. The container registry does not. So we shovel a bunch of crap into the container registry. That's what's going on here. And yeah, so that one succeeded. So this is churning away. So I think the tests take like 20 minutes or a half hour. I wish they were faster, but that's where we're at. And I think that's a good opportunity to sort of switch gears a little bit and do a tour of the source code while those run, because I don't want to ask for this pull request to be, or the merge request to be reviewed unless the tests actually pass. which in fact I just realized they're not because the error messages changed and we're going to verify those. All right. So let's look at some source code. How do we do that most effectively? I'm just going to close all the editors. And okay, so this is the top level directory for Charliecloud, right? The top level, you're going to find some sort of routine different things. You saw the autogen.sh earlier. Configure.ac is kind of intimidating, but this is a programming language called M4, which is a macro language that is very exciting, and for some reason Autotools uses that. This is what checked for the existence of all that stuff and gave us the report. One thing that is a little quirky about our configure is that a lot of that report is informational. Like, it's not actually, it doesn't affect the build at all. It just tells you what's going on, and then if you actually use that dependency and it's not there, then it will fail. But the report is useful to people. It's a makefile thing. We have this file here, the version. That's just what version is it? It's trying to spell check it, I think. Oh, it thinks it's C++. All right. See, C++. So who in this room is familiar with Autotools? Really? I would have thought you would.
I run auto.
Yeah. Writing
When
them.
I looked at what's inside it, I said, no, that's not for me.
That's a very fair reaction. Anyway, so the file we actually write is this makefile.am. Automake converts it to makefile.in, which is terrifying. Autoconf converts it again to a makefile, which is shorter than I thought, just 800 and some odd lines. Anyway, it's fairly straightforward, right? So we say things like, these are subdirectories we care about. Here's some files that we want to include in the distribution, i.e. the tarball. This does some path adjustment stuff. There's probably an issue somewhere. So this is kind of a more routine thing that we have actual code inside a make target. The point of automake is so you don't have to do that. I don't remember exactly what was going on there. So bin is that's where all the C source code lives and the executable Python code, right? So makefile.am in here, right? Bin programs, this is automake magic, right? The underscore programs, wait. I think both the bin and the programs is magic, right? But it's saying that we have two programs that need to be built, and they're C programs, right? So then, here's our headers, and then if we're building with Squash Fuse, we also have Fuse. If we're building with JSON, we also have this one, setcomp, etc. This derives the C sources from the headers, right? More stuff. The header files, I just put everything together in an all.h for good reasons, I'm sure. The shell scripts don't need any building, but we need to tell automake they exist. I'm not going to go into this level of detail on all the directories, but this is sort of a sense of how the make files work, right? Python scripts, those get run through sed to substitute. this is the little, this is the little literal string that appears in the file, and then this is something that is not literal. It's substituted by automake. So that's how we get the right Python interpreter into the scripts. And that is for sites that want Charliecloud to be using a specific Python rather than whatever's in the path. Okay, so this one is sort of like an example containerization program that's a little bit easier to read than the real one. Oh, I know what I was going to do. We're going to go to a different branch. What's it called? Right. And that is because the Python command line just got a lot simpler. And if we run into that, I don't want to show you the old way because it's kind of scary, right? But this is the beginning of chimage.py. I don't know. Right, so there's this Python program, goes to main. This used to be like 300 lines long, and now it's not. But we parse the thing. Something I think is pretty neat, though I use it less than I thought. So if you write Python, you're used to the if name equals main being like very short. This actually injects a breakpoint into the program that you can specify in the command line. And I thought that was pretty cool. And it does weird stuff like re-importing, modifying code in place and then re-importing it, and it does work. But we were thinking about the Python, or the C code to start, right? So we have, this is main. We have a big table of the command line options. My hope is to change this at some point, right? Here's our main, a bunch of initialization. This is the structure that sort of like defines the container, right? So I talked about hopes for a lib Charliecloud. My hope would be that you could build this structure and then pass it in to like sort of the containerize me function, and it would do the thing, right? And this is like the different image formats that we can do. This is setting up the CDI stuff. Okay. And then this is sort of the meat of it, right? Containerize, and then we run the user command, right? Core, I bet the H files would be, maybe. One thing I do want to do is document all this better so we could just be looking at a website, right? But this is like the actual containerization functions, right? So things about binding and containerizing. Run user command was in here. Env.c is environment variable handling, which turns out to be a little bit hairy because we want to, there's the container environment and then the environment for the chrun itself. We separated those recently. fs.h is all sorts of file name operations. These are some wrappers that we had written. Globbing something or other, making directories in fancy ways, path manipulation, that type of thing. Fuse is the fuse business. Public function is fork, right? But this is this runs the fuse loop. So basically, what this is doing is it's setting up callbacks to give to fuse. And Megan is responsible for a lot of this. JSON, for the time being, is just the CDI stuff. List is list manipulation. Turns out we need a lot of lists, and we don't do things very fancy. These are just arrays and some functions to manipulate those. that makes our life easier. This sort of reflects kind of the philosophy of simplicity, right? That it's just an array. We don't work too hard about optimizing memory, those types of things. This is logging, so this is all the logging functions. These are the macros that I was talking about, right? Assert that it's true or false, use a message or not, include error no in the message or not, right? So there's a family of these. What else do we have? There's the memory stuff. So this is allocating memory. Talked about how we never deallocate memory, which is kind of fun. misc.h is just a few random things. Setcomp. This is a short header for code that's actually kind of complicated, but this is
What are you doing with sec?
so we put in a setcomp filter that intercepts certain privileged system calls and just returns success. And this lets us build in an unprivileged way, because it turns out that package managers don't actually care if their privileged things happen or not. We have a whole paper about it. It's pretty cool. String handling, because C's not all that great about string handling. So it's a very quick overview of the C stuff. Let's see, doc. So doc right now it's written in restructured text, which I dislike. But like this is the chrun documentation, and it corresponds to all right, so if we look at main, we can build it to this web page. We can also man-l, I think. Yeah, doc man. Oh, I've done this before, right? But we also have man pages. This is mostly because Debian requires them, but it seems kind of neat. So that's what doc is. Examples. So this is a bunch of Docker files, more or less, right? So, if we choose one at random, this is one of the test images that the Charliecloud test suite uses, right? And there's a structured naming convention, so it can pick these up and build these images. Some of them are more complicated, right? So if we have a lamps, this is building, I guess, kind of an old version of lamps. And it patches it twice for some reason. And it also provides a bats file to do some actual testing of it, right? So some of the examples are more complicated than the others. What's the scope? Full scope. So we're not really good about doing full scope tests at the moment, but we do have a lamps test. That's a MD code of some sort. I don't remember. Anyway, so that's what examples is. MISC is random crap. So like this, developers have a tendency to just let Git branches accumulate and accumulate and accumulate for years. So this is for example, this is a script to clean those up. Random stuff. This is a script that computes our lines of code that's not the documentation. Packaging, there's not much going in here for the time being, because I don't think Jordan actually uses this. He manages the Red Hat packages somewhere else. And we'll get back to lib. Test is the test suite, right? And there's a whole mess of things in here, right? So we have additional Docker files. There's a script that like validates some sanity checks on the documentation. Bash library. This is more Docker files to test some cache stuff. This is BATS files that go into the test that we saw a minute ago, right? So if we choose one at random, right? Oh, this is a good choice, right? So this loads that common.bash, and then this is a quick test. So this validates that the shared library that we built actually works. Or we build a shared library and then link a little executable against it, and it validates that it works outside the container, and then we do tests somewhere else, I think. Or this tests CDI injection, right? So that's the type of thing in here. Some of these are pretty extensive, right? Like this test is pushing 1,000 lines long. Those build images, the ones in here run images, and the reasoning here is that we want Charliecloud to work in a setting where the system where you're running the containers cannot build them, right? So we want to be able to build the images for the test suite, transfer that blob over to some other system, and then run the rest of the test suite over there. That's why we separate the build and run phases. Unused. That's scary. Okay, so that's test. This directory here is also important because this runs the CI testing that happens on GitLab.com, right? And this actually has improved a lot, but you know, it's a GitLab CI file. Ours tends to get long. Our CI is interesting because we need to build images that we then use for the rest of the CI, right? So that's what this one is, right? CI images, and then it's building these Docker files, and we use those later to actually run the tests, though they're not, well, they're in this other file matrix. So that's gitlab.com, and then lib is the Python stuff, and I guess also some shell stuff, base.sh. Yeah, okay, so that's imported by the shell scripts, right? This also has a make file, right? This it's not very fancy because Python doesn't need to be precompiled, right? But it's, you know, it's listing the files so they end up in the distribution tarball. This is the bundled lark, right? And then there's a few other things. Version.py is built rather than checked in. And how is this constructed? So like, one thing you'll see is that this is the Charliecloud stuff, and we tend to have aliases for those that are short. But it's like, this is the build cache implementation. This one knows how to build images from, I believe, both Docker files and other methods. Though this is, what's going on? Well, this reflects the new command line interface, which I think is kind of neat. So this is defining the subcommand build, right? And here's some flags that it defines. It's also pulling in some flags that are common with the other way to build images, which is using a shell script or an interactive shell session, right? And then this is actually the main for that subcommand. And there's a whole bunch of those. Like if we look into Gestalt, which is that's a collection of subcommands that let you ask for information about how things are configured. There's something similar in there. Charliecloud is sort of like the miscellaneous. CLI is the root or the base class for defining command line stuff. File system is a bunch of file system manipulation stuff. Not right now. And this is actually kind of neat that VS Code can do this. We have a path implementation, which kind of re-implements the Python path thing, because the Python path thing was really slow. and we wanted an actual class, not just strings. Storage manages the storage directory. Tar file, that's our subclass to do tar stuff. So that's what's in file system. Force is the root emulation, and it was named before we kind of figured out what a better name for it was. Gestalt, I talked about image manipulation stuff. So what's going on in here? These are going to be functions that I don't quite remember. Oh, it's okay. So we have a class that's what's going on here. We have a class that represents a container image, right? And there's a bunch of things you can do with it. Reference represents an image reference, right? So when you have like that localhost colon 5000 / something or other, that's an image reference. Tree is a Docker file parse tree. And then IR tree. This is where the actual Docker file interpretation happens, right? So we have a main loop, and that does some things. There's some bare functions. Now we're getting into the Docker file instructions, right? So this is the base class. This is things that copy things. Instruction.
You're out of time, by the way.
I'm out of time. Okay. And this is the, okay. I'm almost done. So this is the type of thing that gets you to actual instructions, right? So argument. This is the arg instruction. Comes in several flavors, right? Whether it's before or after the from, and whether you're using an equals or not. I think. Anyway, it keeps going. There's one of these for all the instructions. Modify is the shell script thing. Registry is for talking to registries. And I think we can declare victory. I don't actually have anything next, so I can chat with folks for a little bit more. Maybe we can get snacks at the same time. But that's the Charliecloud source code, and maybe the tests passed, but of course they didn't. Oh, that was a different one. That was a different one. I think this is being overly optimistic.
That wouldn't happen if you closed out your tabs.
Well, no, it'd be worse because I would have to find it and open it again. Okay. So, Charliecloud for noobs.
Thank you, Reid. I appreciate it.
You're welcome.
Oh, if anyone